How do I get these two? These two also I can get by putting one more transformer. Then when this is input, when this is positive, this will be negative, and when this is negative, this will be positive. So people used historically when NPN transistor was not a very popular transistor, but PNP was more popular at that time in the early days of transistor technology. Transistors were only PNP transistors, NPN came much later, comparatively later. So at that time people used this kind of a circuit using PNP transistors and then use two transformers, and the transformer bandwidth of this transformer must be same as the bandwidth of the input signal here, and input signal at least with an audio, which means this was a uniform bandwidth up to at least audio frequencies like about 10 kilohertz or 20 kilohertz or something, and that became a big problem. To make a transformer having that kind of bandwidth of 20 kilohertz, having a transformation ratio constant for all these frequencies. As you know that such a transformer will never transform DC, right? So if the signal contains DC or very low frequencies, the transformation ratio is almost 0. So as a result of that, we don't have low frequencies for cutoff and only high frequencies you can do it. But if you go to very high frequency, then all kinds of state capacitance will come into picture. So there are another problem. So some bandwidth between something like about 50 hertz to about 10 kilohertz was all that we could get using the transformers. 50 hertz is a very bad cutoff frequency for music, because most of the tabla and all this fall in that region. So your low frequencies were distorted, not distorted, not faithfully reproduced, the bands. So as a result of that, this amplifier was not having a very high fidelity amplifier because of the transformer design. And the very few people used to make this audio, this kind of transformers, and they used to be quite expensive. Fortunately, the situation got changed when PNP and NPN both were available. Then they said, okay, then I have this PNP, NPN, I don't need a transformer, I do the following. This is loudspeaker. Now see what happens. When this is positive half cycle, this will conduct. So I will give you current through this like this. When this is negative, this will not conduct, and this will conduct now because a PNP transistor. This will conduct and give you current in this manner. So the minusing automatically took place by the PNP NPN combination. You did not require a transformer to do this minusing. And at the input side, you don't need anything at all, because directly the sine wave is applied here. You didn't require a paraphase signals, one sine wave and other inverted sine wave. We didn't need that. So same signal will be fed to both the bases, and positive side this will conduct and negative side this will conduct. This is the class B configuration, because the device now is only conducting for half cycle. But unfortunately, if you closely observe this fellow and this fellow starts conducting only when VBE goes beyond some minimum value, and that typically like 0.7 volts or something. For power transistors, this value is not even 0.7, it goes to in terms of 1 volt or 1.5 volt or something, because of more of silicon sitting inside. So typically maybe around 1 volt or more than 1 volt. So what does it mean to us? It means to us that if the VBE is more cut off, VBE conducting is more than 1 volt or approximately 1 volt, this will not start conducting until this amplitude reaches 1 volt. So, if you have a sine wave, stop me if you are not understanding. Conduction will start only for this portion. This is your VBE. Until this value reaches, this will not start conducting. Similarly, here this fellow will not start conducting until this value is reached. So, the output current will basically be it will not be a full sine wave, but part of the sine wave with this much portion removed from this side. So, this is what people call as the crossover distortion. The crossover, OVER, crossover. So, because of this crossover distortion, there is a dead band here. Means neither this nor that will be conducting. So, there will be dead band. And if you now see that this waveform and this waveform, this is not a sine wave, so it will have all kinds of harmonics in it. The harmonics leads to distortion. Okay. How do I get rid of it? If I can somehow make these transistors biased in such a manner, is ready for conduction by the biasing circuit, and then of course I can get a full sine wave. Because this happened only because it required so much of voltage for this to start conducting, but I just keep them in such a situation that these are just about to conduct in any case, then the full sine wave will pass through. So, how do I do that? You put 2 diodes, you don't have to put diode, you can put resistors also, 2 resistors here, but logical thing is to use diodes, because this top here VBE for conduction is made up by this VBE already available. So, if you now look at this loop here, this VBE is cancelled by this VBE, so both this will be ready to conduct. Are you with me? This is plus VCC and this is minus VCC. And then what I do? I put a resistor and put a diode on the resistor. The voltage across this is VBE, conducting diode, so the voltage across is VBE, and this voltage across is also VBE. So, now if you look at this loop here, this voltage here is same as this voltage. Right? This cancels with this voltage VBE. Similarly, this cancels with this VBE. So, this now the two transistors are conducting for the full cycle. That means, initially I have biased it in such a manner that the 2 transistors are ready to conduct. By this, I don't have to put diodes, but I put diodes for the simple reason, since there is a diode sitting here, I better put a diode sitting here, so this cancels with this. Normally, people even put more than 1 diode, small power diodes, because as I said, this voltage is usually more than the 0.7 volts. To take care of that, you may require more than 1 diode. So, they put 2 diodes in series, a diode chain. But that is a matter of detail, but biasing is done to make it small amount of base current which will be conducting these 2 transistors in the quiescent state. So, they are ready to take on a full sine wave in the full cycle.